Okay, hi everyone. I hope this video finds you well. So today we are going to talk about recursion, and when we are done with explaining what is recursion and how we are doing that in Java, we are going to have an exercise, and the last thing we are going to conclude this video with is explaining the programming assignment with recursions and lambda expressions. So recursion is the process of repeating items in the self-similar way. And this is the general definition. And I'm not going to ask you to define this in tests or something like that. So basically we say that definition because I want you to understand it in the general way. So generally, recursion is a process of repeating items in self-similar way. So for instance, when a surface of two mirrors are exactly parallel with each other, the nested image that occurs are a form of infinite recursion. Because as you can see in this picture, you're going to see nested images that are infinite. What I want you to focus on is in the definition in mathematics and computer science, because we are computer scientists, so we are focusing on computer scientist definition or computer science definitions. So in computer science, recursion refers to a method of defining functions, or a way of defining functions in which the function being defined is applied within its own definition. Everything is going to be more clear with an example. So basically, you can think of it also as a form of divide and conquer. So a common method of simplification is to divide a problem into subproblems of the same type. In a computer programming technique, this is called divide and conquer, right? And it's basically a key to design of many important algorithms. So divide and conquer, this technique serves as a top-down approach to problem solving, where problems are solved by solving smaller and smaller instances. For example, if you have a big task like this, you split that task into subtasks, and if the subtask is still big, you can split it into or divide it into subtasks. Then you solve the smaller tasks, and then you conquer, go back, solve those tasks, and then conquer until you reach the end, which is up to this point. Now you have a solution after you divided sub tasks of that big task. Okay, what is the advantages of having recursion in my code? So basically, the main advantage is the simplicity of your code, and that makes it more clear and more readable. The disadvantage is oftentimes that algorithm may require a large amount of memory. So disadvantage is it uses large amounts of memory if the depth of that recursive algorithm is very large. And it could be slower than an iterative solution due to the memory used and due to the amounts of seconds we spend on adding stack frame and removing stack frame and processing these things. So the basic idea of recursion is that we have recursive functions that are used to reduce a complex problem to a simpler to solve problems. Problems, actually. It's not one simpler to solve problem. Sometimes it's more than one. So the simpler to solve problem is known as the base case. Or in some other languages, it's known as the ending condition. Recursive calls stop when the base case is reached. So what we say is we have at least two cases in a recursive function or a recursive algorithm. The base case, basically it's a simple occurrence that can be answered directly, and the recursive case, a more complex occurrence of the problem that cannot be directly answered, but instead it could be described in terms of smaller occurrences of the same problem. So some recursive algorithms have more than one base case or more than one recursive case, depending on that algorithm. But at least they would have one of each, one base case and one recursive case. A crucial part of recursive programming is identifying these cases. So if I give you any question, any algorithm that I want you to do recursively, if you were able to identify the base case and the recursive case, your algorithm is pretty much complete, because pretty much you are done. So how do we get recursion in programming? So basically, you know, the main idea of functions is that the stack passes information from in the form of arguments and gets information in terms of return values. This is functions. Like if I have function, you always start with main because it's the starting point of every program. So the stack frame for the main function, as you hear me, I say main function. So if you have another function, it's going to be in the top of the main because it's being called inside the main. So the function itself is going to be loaded in a stack frame above the main function. When that function ends, the stack frame is popped off and you end up with only the main function, right? When the main finishes, that means your program is finishing, you end up with an empty stack. So we use this in recursion because information is passed forward with arguments in a function call, and information is passed back with a return value or return values depending on your algorithms again. So for example, let's say we have this code, and this code is a recursive code. It's a recursive function. We're going to design a function that counts down. We give it a number, so let's say we give it a 3. It counts down from 3, 2, 1, then does something after that. Let's say it says go or blast off or something like that. So if we have this function, the base case, when we do not call this function again is when the counter is 0, right? When the counter is 0. Now, when the counter is 0, we use whatever we do. For example, this function does not return anything, so it's a void function. It writes something. So writes blast off on the screen when the counter is 0. But if the counter is not 0, we print something if we wanted, print the current count, and then call the function again with the decremented counter. So my counter name is current. If the current is 0, I print this function and stop. Now, stop means I do not call the function again. Otherwise, if not stopping, if it's not 0, print that number, then call that function again with the decremented number. So the recursive function make a call to their own function, The base case is going to be this case when the counter is 0, because this is where I say go or blast off, right? Otherwise, if it's not 0, then I call a function again with the decremented value. So usually I call the function again with a new value, And when you call the function again in itself, because you can see this is exactly this name, countdown. So this is called the recursive call. Now let's consider what happens on the stack side. So here is your program. The first thing you visit when you run your program is the main, the first line in the main. The first line in the main is calling countdown with the argument 3. So we have the main function when we started the program. Only the main function stack frame in the stack. And when we call this, we push a new stack frame with this variable current, and we give it the argument 3. So we push countdown frame with the argument 3. This is a new stack frame. The next thing is when we go inside, we check the current, and current is 3. So is 3 equal to 0? No. So we do the else. We print 3 on the screen and call the function again with the decremented value. And you have to make sure where you add the minus. Because this decrementation operator is crucial to your function. If you have that in here, it's going to make a big difference. Let me just show you how that is being done in here. So this is our main, and here is the countdown, right? Here is the countdown. So let me just run this project. So that was doing 3, 2, 1, then blast off, right? Now, if I put these in here, then that is going to be an infinite. Why? Because every time you call this function, you call it with a 3. Is 3 equal to 0? No. So print 3 and call this. So as you can see, it prints 3, 3, 3 infinitely until the memory explodes. The memory explodes and give you this error. It says the error is in testing.java, which is this file, at line 12, which is here. So you are calling this function infinitely with the 3 because there is no stopping for this one. The right way is to first decrement, then call the function. Decrement the counter, then call the function. Okay, going back to our slides. So we called that one, and now we have to call it with the argument 2. So calling that with the argument 2, adds one new frame. Because whenever you have a function call, you push a new stack frame for the new function. Even if the new function is the function I'm inside, it's okay because I'm dealing with that as a totally new function because it's with a new input. And if there is output, if it returns something, not void, you're returning a different value usually, right? So you can think of it as a totally new function. This is why I add a totally new stack frame. So then that decrements that and go with 1. Is 1 equal to 0? No. So call that with a 0. Okay, calling that with a 0. Now we stop. Why? Because is 0 equal to 0? Yes. Then there is no more function calls. I just print blast off. Right? Then I keep returning the value, but I'm returning nothing because it's void. So I just remove the stack frames. So returning from countdown with argument 0 to countdown with argument 1. That does exactly the same thing in here. Keep doing that until you get to the main and the recursion is over. Now the control is transferred to main function. Okay, so what happens if we have done this? -1. Count down with -1. Can you think of what's happening? I'm not going to answer that. I'm going to leave it to you so you think about it and then try it on your Eclipse. Okay, stopping the recursion. So the recursive function must always include a test to determine if another recursive call must happen or the recursion should stop. So usually we should have this. As I said, you must have two conditions. One that tells the recursive function to stop, and one that makes the recursive function a recursive function, which is the function calling itself. This thing, right? This thing. This function call shouldn't be an if-else statement, or something like that. It could be on its own. So actually, if you go there, you can remove else and run it, and still that would work if you design it differently. But if you remove the else in this version of code, in this function, it's not going to work. It's still doing an infinite recursive calls, because if that is enough, it's stop. But then, as you can see in here, we keep decrementing no matter what. So in this case, we had to link this condition to this condition. In my next example, I'm going to give you something that does not link the recursive call to the stopping condition. So recursion uses a process of breaking a problem down into smaller problems until the problem is solved, or can be solved, or simple enough to be solved. In countdown function, a different value is passed to the function each time it's called. As you can see in here, we called with argument 3, then 2, 1, 0, and so on. So I give you an example of a void function, and the next example is going to be on not void function. So eventually the parameter reaches the value in the test, the recursion stops. In our case, that was when the current was equal to 0. So all recursive functions can be converted to an iterative solution. All of them can be converted into an iterative solution. This may be necessary for a deep recursion. A deep recursion is a recursion that has so many recursive call that it will blows the stack out. So you run out of memory. This is what happens in this case, right? You kept doing that, even though this is not exactly of deep recursion, because when we get rid of the else statement in here, that makes our recursive function not exactly correct one. Okay, so the types of recursion is direct. The function calls itself immediately. This is the one we just had with countdown. Indirect, you have two functions. A function A calls function B, then function B calls function A, and then function A calls function B, and so on, until you reach the stopping condition. We have a tail recursive function we call tail recursive function, and this the recursive call is the last statement, is going to be the last statement in your function. Now, many compilers optimize the tail recursion to be an iterative. Basically, they convert that implicitly, internally, they convert this function because it's a tail function. The recursive statement is the last thing in the function. They converted to an iterative solution. An iterative solution is the solution that uses kind of a for loop, while loops, and all these iterative tools. So in Java, we do not have optimization for the tail recursive function. It's not going to convert it to iterative solution. So watch out for this. So we do care about tail recursions because one, Java does not have optimization for it, and in other languages we we leave it to the compiler to optimize it. So it's usually faster than iterative function, and we rely on the compiler to do that. And we even though we know the compiler is going to optimize it in other languages, we prefer to write it in a recursive way because it's easier to understand the recursive version of a code. So here's another example. Another example is going to be the factorial. Now, you know that the factorial basically is the product of all positive integers less than or equal to n, with the exception that the factorial of 0 is equal to 1. So if we have 4 factorial, the answer to that, the result is 4 times 3 times 2 times 1. And that is going to give you 24. That is going to give you 24, right? Now, you can think of this in a recursive way, right? Recursively. How? Is 4 factorial equal to 4 times 3 factorial? From this, right? From this. We can say this is 3 factorial, right? So 4 times 3 factorial. And we say this part is 2 factorial, so this can be 3 times 2 factorial, and so on, right? So you notice the pattern, right? There is a pattern here. So 3 factorial equal 3 times 2 factorial, and so on. So your end condition could be 0 factorial is equal to 1, or 1 factorial is equal to 1, right? So when n reaches 1, we stop. We do not call that again. Otherwise, we do the recursive call. The recursive call in this case is going to be this one, right? This one. What is the stopping condition? Is this one. If num equal 0, return 1. Otherwise, return n times n minus 1 factorial. N times n minus 1 factorial, right? Okay, so if we have this factorial function, so int, and it returns int, it does not return void, it must return something, right? And it takes int, returns int. So if that takes 4, when that returned value going to be received? Now, to answer that, you have to understand very well the stack processes, the stack frames, how they work. So if we have this implementation, we stop only when n gets to be 0. Otherwise, we do n times calling the function again on n minus 1. So the first thing you have done in main is you called factorial 4, right? Factorial 4. So you give 4. So the first thing you did is you give 4. You added 1 stack frame. Then you do that with 3, because with 4 in here, you're going to do is n. When you receive 4, is n equal to 0? Is 4 equal 0? No. So you would do else. Now else, return n times factorial n minus 1. N is 4, right? Don't forget. You would save that for later. you would say that it's going to be saved in here. So 4 times factorial n minus 1. What is n minus 1? 3. So add a new stack frame with 3. Do the same thing. Do the same thing until you get to factorial 0. Now, when factorial receives 0, is n equal to 0? Yes. Yes. So return 1. So start returning. So that returns 1. Now this function call, the one when you call that for 1, returns what? Substitute this function, substitute the returned value from this one. Remember that returns something. You returned 1 from this one, right? So substitute that in here, plug that in. Now we have 1 and n was 1, so n times 1. Return it to the lower stage. Now that returns also 1. Keep doing that. Plug that in with the n that was when the function was called. So 2 times 1, return it. You return 2. Then 2 times 3, that was 3. And that n, when you call the function, this is, so when I say 2 times this value, return value, this is the return value, this, and this is the n, right? So 2 times 3, back with 6. 6 times 4, go back with 14. So you go back to the main with the value of 14. So that plugs that in here and prints eventually for a 24. Not 14, 24. 24. Okay, so here's an exercise for you. Here's an exercise for you. Write a recursive function that prints a given digit in a separate line. So if I give you this, 1, 2, 3, 4, here is a function name, and I call it right vertical. And that takes 1234. And that prints 1, 2, 3, 4. And this is integer. So it's not a string, so you can print character at. No, it's an integer. So you have to think of two things always. The ending condition, the base case, and the repeating pattern, the recursive calls, right? So stop the video, pause the video, and start working on these. But here is a hint. Here is a hint before you pause the video. The ending condition could be when you get up to this single digit number. The repeating pattern could be when you call a function for all digits except the last digit. Print out the last digit. So this is going to happen. You call the function for all digits except the last digit because it's going to be your stopping condition in here, right? And you print the last digit, you print out the last digit. Pause the video, think about it, and come back, see how easy you can do that. Okay, assuming you came back after pausing the video. Okay, so here is the solution. The solution, we have the main, we called right vertical, 1, 2, 3, 4, 1234. Now, the ending condition is going to be when the number I have is less than 10, which means it's a single digit number, right? If that is the case, you can do system.out.println. Otherwise, right vertical and give it num divided by 10. Now, actually, what we have done is we benefited from the from some things that Java does for us without our without us having anything to do with it. So what is that? When you divide 1234 by 10, what is the result? Now you would think that, okay, this result is 123.4. No, it's not. You're wrong. Why? Because the result is just the 123. Because this is an int, and this is an int. Int divided an int gives you an int. So how would I give the remainder? The remainder is using the modulus. So you would get the 0.4, actually the 4, as the modulus, right? So 0.4 times 10. Now, how would I get that? With the modulus, right? So what we have done is right vertical, keep doing that, and every time take a number. Take a number out, take a number out, take a number out, until it's single digit, print it. Then go back and print the numbers of the remainders. So the remainder after we have, so if I'm going to do that for you, let me just clean this first. So 1, 2, 3, 4. Basically, this is not going to print anything. And here's what we print, right? Here's what we print. So we call the function on 1, 2, 3, 4, printing nothing. Then we called it on. We checked, okay, is this less than 10? No, this is 1234. It's not less than 10. So skip, go to else. Write a vertical num divided by 10. 1, 2, 3, 4 divided by 10. So we call it in 1, 2, 3. Do we print anything yet? Not yet. Do it for the 12. Print anything yet? No. Do it on the 1 in here. Still in here. Do it for the 1. 12 divided by 10, that gives you 1. So when you do it on the 1, you print the number. Print 1. Printed 1. Right? Then you go back and take out this stack frame. With the 12, when you go back to the 12, you go back with nothing because it's void, and you print the next statement. The next statement prints what? Prints the 2, because when you have a 12 mod 10, that gives you 2, right? That gives you 2, so you print 2. And you print with println, right? Because we wanted that in vertical, in a separate lines. So then we pop the 12 off. Then after we pop the 1, 2, 3 off, then we do 1, 2, 3 mod 10. That gives you the 3. So 3, same thing with when you finish this, you print this one, and 4. Here is how it's actually being done. Okay, so when you solve that, this exercise, I want you to upload the Java file that contains your code. Basically something similar to this. Hopefully you didn't struggle and you did solve it yourself. So upload the Java file that contains your code in this assignment. So upload it there. And now it's time for me to give you programming 3A. Now with programming 3A, it's 50 points. And it's going to talk about, if you downloaded this file and open that, it's going to be talking about 2 things: recursion and lambda expressions. Let's start with recursion. 25 points on each. So in recursion, I'm asking you to write a recursive function about the Fibonacci numbers. So if you know in mathematics, the Fibonacci numbers, commonly denoted as f of n, form sequence called the Fibonacci sequence. such that each number is the sum of the two preceding ones, starting from 0 and 1. So for example, you know that f of 0 is equal to 0 and f of 1 equal to 1. And any other number I give you to tell me what is that number, you know that it's the result of the sum of the preceding two numbers. So if I give you, okay, what is f of 3? So you'd say f of 2 plus f of 1. F of 2 equal 1 and f of 1 equal 1. So that is going to be 2. If I tell you, if you're up to this point in the sequence, and I tell you what is f of 6, f of 6, then you would say, okay, f of 5 plus f of 4. F of 5, 5, f of 4, 3. So 3 plus 5, it's 8, and so on. So what I want you to do is three things. One is to write a recursive function that would find the nth number in the Fibonacci sequence. So for example, if I said the nth being the 40th, so the 40th number in the Fibonacci sequence is going to be this number. So this is for you do that for the recursive function, and you do that in iterative function. So function that calls itself the recursive function, another function you call iterative function that does that using a loop, whatever you use, while loop, for loops, do while, whatever you want. And that finds exactly the same thing. Now, why do I want you to do that? Why do I want you to write the same function, basically function that does the same things, two functions do the same thing, because I want you to compare them. So I want you to compare the elapsed time by both functions in milliseconds. Now, how you're going to do that? You're going to do that having long start equal system, the current time millis. Do you have your function call? The function call, for example, is going to be in this line. It's going to be Fibonacci 40, right? Fibonacci 40. Then that is going to print this and blah 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 everything, and then you do long finish equal system dot current millis. That takes the time before starting the function, that takes the time after starting the function, and then you have the difference. And print the difference. Now, why do I want you to do that? Because that proves that the iterative solution is going to be faster than this is almost 0 milliseconds to find this number. That took about 256 milliseconds to find this number. Now, it's going to be different for you depending on your machine, depending on your processor, and all these things, right? So it's not going to be exactly 256 for you. It was for me, but it's going to be different for you. So to see significant difference, it's going to be 40. Like you use big numbers like 40, 45, and so on. So lambda expressions, the lambda expressions homework is going to be, suppose we have a function interface called array processor that is defined like this. So I defined that. So you would take that, and for example, if I would have everything in one line, I'm just going to do this. Let's have it in here. So now I have my interface, but because if I have something called public, it has to be the same name, so I'd remove the public, so problem solved. So usually if you have something public, it has to be the same name as this one, as your file name. But I don't want to change my file name, so just remove the public. So right now I have interface, and this is function interface. Function interface is an interface with one abstract function. So here is the function interface, right? And then what I say is in your main, you're going to call that function. So here is my main. I don't want this. Let me just comment this one, or just remove this because it's going to be something else, right? Let's just remove this, a clean main. So now I have my main with a double array of 10 numbers, and then I say array processor this. I use lambda expression to get the length, of my array. So this is going to be much simpler than anything you have seen. It's just going to say array, return array dot length. You can do x and do x dot length, whatever. Anything would work, right? If you understand lambda expressions. So we put the result in here. And this is generally, right? This is taking any x and returns the any x's dot length, and x would be an array because length is going to be applied to an array. Now, because it's in here, right? It's going to be in here, in the array processor. Now, you can do this variable numbers of elements dot apply, and you give it the first list, and that prints 10, right? Let me just show you that. That prints 10. Why 10? Because you have 10 elements. Now, what I want you to do is, you have this one. I want you to comment this one and to write another function declaration that would find the maximum value in the array and test it on this one. So for example, the only changes you're going to do each time you for these bullets, you're going to do for example double max that takes a double array, right? And you call it max. That returns double. So then the next change is going to be this. What's inside of here? It's going to return double the max, right? Double max. So this is what you're going to be changing. Like return, you're going to do something like that. I'm going to do the first thing for you. Int max equals 0, or and then you do for loop for each it's double array, so it's going to be double x in my array. No, not x, because I have an x in here, so let's just call it k for each element k in my array x. If max, usually what I would do is put the max as the first one. It's safer this way. If max is greater than x of not x, it's greater than k, max equal k. Then when you're done with this one, return max. Now, if we do that, that would say, okay, can convert double to int somewhere in here, because it's of type double. Okay, my mistake. And then we call it max, and we give it the first array. Okay, now it works. Now, what is the maximum in here? It says 1.7. No, there is something wrong. Oh, we have 1.7. Okay. I should be doing this. If k greater than max, and run it. Here it is, 12. 12 is my maximum number. So I just did that for you. The next thing you do is, again, you do that, and you change this. Now, what I want you to do is comment this one, and start a new one in here. Comment this one and start a new one in here, and so on. Keep commenting and doing the same for each one, or you can have each one in a separate file. Basically we have pretty much 20 points on each. plus the if your output is good to read or easy to read, and program this if you have the program description header, this one in your code. So that's it for today. Have a great day and catch you on the next one.